Cisco EIGRP is an enhanced distance vector routing protocol that runs the dual algorithm, or the diffusing update algorithm. This protocol is classless and it uses AS numbers or autonomous system numbers, which are used to define a group of routers that should share information. EIGRP synchronizes topology tables at the start, but then only sends updates when changes occur. EIGRP supports both IP version 4 and IP version 6 and has an efficient method of neighbor discovery. EIGRP has also recently become an open standard, where it has been Cisco proprietary in the past. In order for EIGRP to discover its neighbors, 3 requirements must be met. First of all, the AS numbers or autonomous system numbers must match. Second, it must be receiving hellos. And third, these hellos have to contain identical metrics, which are called K-values. EIGRP uses Reliable Transport Protocol to talk to its neighbors. It does so through the use of multicast group 224.0.0.10. If no response is received, it then switches to unicast. After 16 tries with no response, a neighbor is declared dead. In EIGRP, the max hop count can be up to 255, but is 100 by default. The hop count specifies how many routers a route update can pass through before it is discarded. It limits the size of the AS, but has no bearing on metrics. Here are a few specific EIGRP routing terms that you need to know. First of all, successor. The successor route is the best route in the remote network. The second is a feasible successor, which is the backup route to the successor. Third is feasible distance. The feasible distance is the best metric from all paths to a remote network. This route is the route that gets installed in the routing table. This metric is the metric reported by the neighbor plus the metric to the neighbor reporting the route. Reported and advertised distance is the metric of a remote network as reported by a neighbor. The neighbor table is a table of all the adjacent neighbors to that router. The topology table is filled with neighbor updates, and the dual algorithm calculates the best route, takes it from the topology table, and feeds it into the routing table. The EIGRP composite metric is based off of 4 different factors. The first one is bandwidth, the second is delay, the third one is reliability, and finally, the load. It is worth noting that only bandwidth and delay are used to determine the best path to a network by default. Please join me for our next lesson, examining OSPF.